Hi, everyone. Welcome to the second class on proof automation. So today I'm going to talk about ethics. Now, just a note, I'm like 100% not an ethicist. I'm a proof automation person. On the other hand, I think this is kind of as foundational to this work as type theory is. And a lot of my friends who are ethicists have convinced me recently that it's our responsibility to know about ethics, you know, whether or not it's what we specialize in. All of us, like everyone in computer science. So that's why I'm talking about this. It does mean that, as someone who's not an expert, I'm not going to have the best ethics lecture ever. Um, some of you with more ethics background might find some of this a little obvious, but I think it's really important to bring up, especially, because when I was learning a lot about programming languages, I didn't have much of a chance to learn this stuff. And I really wish I had. So with that in mind, last week, when I started this off, I gave you this example of this cell4 verified operating system microkernel, which is inside of an autonomous helicopter, used to make it resilient to hacking. Now, when I first heard about this example, I thought this was kind of an unquestionable good. Not only are we verifying an operating system, like we're also making an autonomous helicopter safe. Like, of course we would want that. And it took me seriously several years to realize that when people say autonomous helicopter here, they often actually mean military drone. And this statement here, I think it's a lot less obvious, like what its truth value might be. In fact, I've heard really valid disagreements about, whether or not we should want our military drones to be safe. Lots of questions open up here, like, who is it actually who benefits from a safe military drone? Like, what are we verifying? What could go wrong here? Uh, you know, if you're like hacking into a military drone, is this justified? Like, how are you hacking into it? What are you doing with the hacking? Is it just to prevent death? Or are you trying to intercept it and cause more harm? Is it inherently bad for me as a researcher to participate in, anything military related? If this drone harms someone, who's responsible for that harm? Am I responsible if I've built some automation that, proved this operating system secure in some way, and then that operating system is used in the drone? Probably there are degrees of responsibility. And then, does the good of building some of this verification technology, like in the case of Cell4, verifying an operating system microkernel, does that outweigh the bad? Like there's a lot of good stuff you can do with this. And, I think when we think about ethics, like people in verification for a long time have had this kind of axiom that verification is just inherently good. And I certainly held this for a while. But I think there are like really valid ways to disagree with this. Like it depends a lot on what we're verifying. And reasonable people could disagree on like whether it's a good thing to verify a military drone. So I think probably more accurate, it's that verification is a technology. It can be used for good, it can be used for evil, everything in between. People might even disagree on what's good and what's evil. And furthermore, proof automation makes verification easier, which makes it easier to do good and to do evil. It's really kind of a foundational technology. And this is, a dilemma in ethics called dual use. When your research can be used, for good and for evil. And you don't necessarily know ahead of time what it's going to be used for. And I think this dilemma is just absolutely everywhere in programming languages, formal methods, software engineering. Uh, we're building a lot of these foundational technologies, and they can be used to verify everything from our cancer therapy machines to our military drones, and we just don't know ahead of time. So this is like absolutely everywhere. So this is one of the reasons that I want to talk about ethics in proof automation. And I'll talk a little bit also about just ethics in your research career a bit more broadly. Now, ethics in general, I think, has like more questions than it does answers. It usually doesn't give you the answers to everything. It kind of empowers you to ask the right questions, to figure out if you're doing something, reasonable, and to foresee like the harms that you could cause with your work. And with that in mind, there also isn't really like a single universal ethical framework, at least in my opinion. So in this particular lecture and in this class, I'm going to be using the ACM ethics code as one ethical framework. It's a framework that I like. I think it's really approachable. But furthermore, those of you who are submitting research papers to ACM conferences are actually bound by this. And I'm also bound by this as an educator, to sort of like spread the word to the community and let people know. So I'll be talking about things through the framework of the ethics code, which is why this is your reading for this class. Now, the ACM ethics code you can find on this website, so I recommend reading it. And it opens with some sort of general ethical principles that a computing professional should follow. So a couple of these already come up when we're looking at our verified operating system microkernel, used inside of an autonomous helicopter or a military drone. We have to ask ourselves, is there a possibility that we're going to cause harm? Is this contributing to human well-being? And I think, again, here we have questions. We don't necessarily have answers. I've heard reasonable people disagree on whether or not, it's harmful to verify an operating system inside of a military drone. Now, these four here, I think will come up a lot more as machine learning becomes more relevant, to proof automation. Although I do think they also come up in anything where data is involved and where sometimes even just tool design is involved. We're going to keep seeing more and more of this. So, for example, I think one good example for this is this GitHub Copilot like code autocomplete tool that came out of a collaboration with GitHub and OpenAI. So this is mostly for completing programs. It can also be used for proofs as well. It's kind of language independent. And I think a lot of these questions come up here. For example, be honest and trustworthy. There is a possibility that this tool can actually introduce incorrect code. So does it communicate that it's, not trustworthy in those cases well enough? Or, is the person using it likely to just believe what it says and, introduce bugs into their code without knowing? This could cause harm. Then, do we have data that's actually representative, or are we somehow missing out on things like, there's a lot of natural language in there. It's probably mostly English. Are people using it in other languages going to get worse results? Respecting work here, there's this whole disagreement about licensing. Did Copilot do a good enough job? Really, Codex, the model beneath it from OpenAI, at respecting the licenses of, all of the data at training time. Should they have considered all these licenses before training? Or is it okay if the data is public and it's not being reused as is to just kind of ignore licenses? And then, respecting privacy. Like, did they do enough to protect the privacy of people, whose data shows up inside of the training data? Can, private information leak? Can you consider it private information even if the data itself is publicly available? So again, all questions, like room for lots of reasonable debate here. So, that's the first part of the ethics code. And I think actually verification, can make some of this a lot better. So like we had this 1.3, be honest and trustworthy. I think, there's a case for proof automation, making tools like Copilot better in the future. Like maybe we can not only introduce code, but we can, introduce proofs that the code behaves a certain way. And then we are building something that is more honest and more trustworthy, even though a lot of these other questions still apply. So, it's not like verification is an inherent evil. Again, I think there are some ways where it's reasonable to think that verification is kind of inherently good. Two other things, it helps us build high quality work. This shows up as our professional responsibilities in the ethics code, and design systems that are secure. Like these are good things. And, I think sometimes this can really help us evaluate our systems completely. Think about all the risks involved, make those clear, communicate them by way of specifying them. But there is still, a way that this can go wrong here. For example, we might specify and prove something that doesn't actually correspond to reality. And then we haven't thoroughly evaluated, all the risks of our systems, and we're kind of being misleading there. We're showing something is true, and this might give people false confidence. Similarly, when we talk about verifying a system, we often say, it's totally correct, it's totally secure, when we really mean that like certain properties that we've proven provably hold. And I think it's really important to communicate that well. Otherwise, we can really go against 2.5. And then also this like be honest and trustworthy point from the first part of the code. Now, some of the parts of the code have a lot more to do with your responsibilities as a computer scientist in general, not really for the systems you build, but just for your work environment. And these kinds of things come up in both industry and academia and like everything you could possibly do. So I think they're important to know. One that I like here is this know and respect existing rules pertaining to professional work, which doesn't sound that interesting as is. But one thing I really like about this is that the ethics code, actually encourages you to challenge rules that you find unethical. So when I see this point, I think a lot about my friend Meg Mitchell. So she was recently fired for Google from sort of, speaking up about something that she found unjust within Google and the way that she went about that. And Meg, started by challenging this rule from within, challenging all the things that happen from within, talking to people who were sympathetic, kind of encouraging change. And then, kind of realized that at some point she had to turn to like some kind of whistleblowing. And at that point, I believe she like documented everything she was doing, was trying to be as ethical as possible, cause as little harm, and then, violate like on technicalities some rules within Google. Uh, and she did face consequences for this. She was fired. And I think she, knew that this kind of thing could happen. And she strongly considered consequences, not just for herself, but for like all of her teammates. So, I really think when it comes to Meg, like she is 100% someone to look up to. I admire her a lot. But, I also think, yet again, we have lots of questions like, is it reasonable to expect this from everyone? When you say consider potential consequences and accept responsibility, that's going to depend a lot, those consequences, on your individual life situation. It's totally reasonable if you encounter something unjust in your workplace, that the consequence of getting fired, could mean that you like can't support your family or something like this. And not everyone might be willing to, go through this. So I would definitely, take this rule very seriously, like this guideline, this responsibility, like every single part of it, from knowing the rules, respecting them, challenging unethical ones, carefully violating them if you, have tried challenging and it didn't work, but considering the potential consequences and accepting responsibility, only if they are actually acceptable consequences for you and for other people impacted. So, one of my favorite parts of the code. Now, while I'm kind of at this Google thing, I kind of want to give a bit of an aside on sponsors. So far I've given, 3 examples, and 2 of them, came from, one was DARPA and one was Google. So 2 of these actually came from people who are, or like companies that are sponsoring me in some way, or entities that are sponsoring me. Like, I do have grants from DARPA, and this summer I will be working at Google as a visiting researcher. And I think actually, if you look at verification as a field, you'll find that a lot of money comes from the military, because the military is understandably very interested in building like secure systems, and this makes it much easier to build these systems. But the money used for that, the things that we develop, it's typically not like we are just verifying a drone. It's often like we're building automation to produce these proofs, which can be used in everything from our healthcare devices to our drones. So, it again opens up lots of questions. And in fact, when I think about this a lot, I often talk to my sister. She's a grant manager at the Department of Defense, and she does work on like health disparities in cancer research. And, I think that the Department of Defense I believe funds more cancer research than any other entity in the US. So again, like just because something is military doesn't necessarily mean that it's bad, but I think it's 100% reasonable to question it, to debate it, to talk about what our boundaries should be here. I think for some people, it's really, really reasonable to just totally reject all military funding. I've seen that line drawn, like if you don't know how it's going to be used, then maybe it's just not safe. I've seen lots of people who will accept it in any case where they feel like they can do benefits. I think I kind of fall into that category. So I think this is reasonable to challenge, but again, more questions than answers. Now, when it comes to Google, on the other hand, when I was considering this, the kind of main thing that incentivized me to work with Google, even though I did find this situation unjust, is that there were some really cool collaborators there and I wanted to work with them. But I think it's 100% reasonable. And I've seen people make this point to me that like maybe I shouldn't be doing that, until harm has been repaired. And I've considered this, and again, yeah, more questions than answers. I think that there's lots of room for consideration there. So when I considered this, the main thing that came into play for going to Google after all is that I found out that there were some really good people within who were interested in repairing harm and kind of working on it, and like that just changed. It just changed the lines that I was willing to draw. But again, questions, tons of them. Answers, very few. Uh, Now, even with all of this, like even, with all this sponsorship information I've given you, I think it's really important for me to communicate this, these ethical principles and so on to you. In fact, it's even embedded like inside of the code that I'm supposed to spread the code as a, leader in computing, like as an educator. So any of you who, acquire leadership positions later on will be in the same kind of position here, where you'll be expected to kind of spread this. And I think it's really great to do that because I would really love, students who are not just contributing like technical ideas. That's really exciting. But I think they should also be contributing ethical ideas, like challenging advisors and like, okay, I might get in trouble for saying this to your advisor, but for sure, if I'm advising you, like, please challenge me ethically if I do something that you don't think is just. I think that's like a wonderful thing to do. Because then we can really make sure that, when building, modifying, systems that are, kind of core to society's infrastructure, we are really contributing to the public good. So please challenge me at least, and possibly other people, but be careful. Everyone's different on how they respond to being challenged. So that brings me to what you can do if you are in a situation that you don't find ethical. I think in a lot of situations, where kind of just talking to the person isn't reasonable or won't work out, it is worth noting that there's this committee, this ethics committee through the ACM, and they're really great. And you can report things to them, or you can even just talk to them without officially reporting to just get an opinion on like what kinds of things you should consider. They're very professional. In addition to this, sometimes direct confrontation is enough. And I think the code actually like encourages you to kind of try to bring things up directly to people before you go off and make an official complaint about something. So direct confrontation, like one example of this that I'd be happy with is like, say I have all this funding from DARPA. I tell my students where funding comes from, for grad students. But if a student comes to me and says, I'm actually not at all, comfortable receiving DARPA funds, then I will go and apply for other funding for them instead. Although it will take time, and there might be like some time where this person has to TA or something like this. It's not super easy, but that's one place where confrontation might work. Now, I would be careful about generalizing this to other advisors because again, there might be advisors who are not at all comfortable having that kind of discussion of like where your funding comes from. So I think you should get an individual read on your advisor for this. And that kind of brings me to another point here, which is that directly confronting people about things that you consider unethical is not even like not always possible. It's also not always safe. Sometimes people will retaliate if you do this to them. Or if you end up having to file a complaint later, this might reveal your involvement in that complaint and put you at further risk of harm. So, it's worth being really careful about. I've done this kind of thing a lot, and I found that some people in positions of like profound power will react really wonderfully to being directly confronted in a respectful way, which is awesome. Some people will kind of push back and like get a little bit scared, um, but they're still willing to have some kind of conversation. And then some people, I think, will actually react really like poorly. They don't like that kind of confrontation. So like, yeah, you just have to be, understanding of the kind of risk involved in confronting someone about something you don't consider ethical. So other things you can do are, ask one of your mentors, ask an advisor. You can, talk to your friends, your lab mates. You can get into the policy, for the department, the computer science department here. You can get into SIGPlan policy for the whole programming languages community. You can get into ACM policy for all of the, computer science community. Uh, or, you can even get into national tech policy. And I think this is one of the most powerful things that people can do. And I'm really excited that a lot of students in the kind of generation of students after me are really considering this as a career path. So I think regardless of your expertise, it's one thing to keep in mind that this is another path in addition to like academia, industry, and sometimes it's something that you can do like alongside your work in academia or industry. So, with that in mind, on the course website, there are a number of case studies, related specifically to proof automation for ethics that kind of use the ACM ethics code as like a framework for thinking. And these are discussion questions. And so for the next class, before the next class, your paragraph, for one of these case studies is due on the class forum. So you should, 100% post that. Your paragraph for the last class is also due next week because of, the fact that this is asynchronous still. And then also, because we'll be starting up in person next week, the paragraph for the next class will also be due. So you should definitely get started on that if you haven't gotten started yet. In addition to this, if you have a chance, I think you should sign up to facilitate a discussion. So there's a forum post on this, which is linked to from the website. And, it's just nice. It's kind of like first come, first served. So you should look and see which discussions interest you the most. And, with that, we've, now covered some of this ethics stuff here. Next week, we're going to talk a lot about foundations. We have a reading related to foundations, and we're going to discuss, the foundations of proof assistance. So then we're going to touch on things like philosophy of logic, dependent type theory, language design, compilers. So I hope it will be a lot of fun, and I'm looking forward to it. And I'm looking forward to seeing you in person. But for now, I hope you all feel like informed and empowered to ask questions and to do the right thing with that information. So I will see you next week and have a wonderful weekend.